Okay. Right. Seniors are done after vectors. Um, right. Thursday we have a partner quiz, right, for F period. G period also is a partner quiz. This is for both all the people in APAC right now who are missing this. I think we can get this done in one section. If you guys haven't already got your calculators, we're gonna try to just get through this. It's not super difficult. I feel like you already know some of this. So in the last sections, we described ways to talk about center and spread of data. So you can have the mean, which is the average. You add them all up together and you find the average. You could have the median, the exact middle number. Mode, not so useful, but whatever. To each their own. There's always a time and place for all these. And then the standard deviation or 5-number summary, it gives you a lot better information, right? It tells you how it's spread out. A low standard deviation means most people group together. High standard deviation, it's really spread out. All right, and then the 5-number summary, remember, it's your minimum, your first quartile, your median, aka your second quartile, your third quartile, and your max. These are your 5 numbers. So, distributions. The center and spread of one variable data. That's all we're gonna focus on. If you're a junior, you could take AP Stats next year. Believe I recommended you for AP Stats and Calc, all 3 of you juniors in here. Cool. I feel like all 3 of you would be successful in either one, both, whatever, your choice. What else? So, to best describe the center and spread of data, you have to identify the shape of the distribution. So, you could have asymmetric. Literally, it's like looking in a mirror, right? The left side is the same as the right side, right? Notice this left side, roughly the same as the right side. It's symmetric, right? So notice the mean and the median are at the same place. So there are SAT questions about this. You could have negative or left skewed. So you see the mean is to the left of your median, and there's a tail dragging out to the left side. If you're dragging out to the right side, you have a positive skewed distribution. Meaning you have your mean is higher than your median. More of your numbers are on the positive end. So when a distribution is symmetrical, the mean and median are close together. But when you have it skewed, so you learned about skew lines and skew in geometry, they're not really together, they're going in opposite directions. Skewed is shifted, right? You have a shift left or right. So in a skewed distribution, the mean is closer to the tail, to one of the ends, than the median is. The median is less affected by outliers. It's literally the middle number. So we say it's a resistant statistic because it's exactly in the middle. But if you think about the way we find mean and standard deviation, if we have an outlier, a really, really number that's way out, it's going to affect it. So these are non-resistant because when we cut out an outlier, it's going to greatly affect the standard distribution, right? It's going to bring it in, and the mean is going to be a little more, accurate representation for the majority of our data. So, choosing summary statistics. When choosing measures of center and spread to describe a distribution, examine the shape. If it's symmetrical, right, and there's not really any outliers, you can use the mean and the standard deviation. Those are wonderful, right? If it's symmetric, beautiful, not really any outliers, you can go ahead and use the things that are non-resistant, things that would be greatly changed if we had an outlier. Versus if we have a skew or one number that's way outside, you know what? It's better just to use a 5-number summary and then we get an overall pattern. Because remember, one outlier blows up our standard deviation. All right, are we good so far? I feel like this is, semi-common sense, especially if you are in psych, you already did this, so we're good. All right, the lab grades of all the students in a bio class are shown. So we're going to construct a histogram using the calculator and use it to describe the shape of the distribution. So, enter in all these. Do you remember how to do it? Yeah, so you go to list, spreadsheet, put them all in the first column, yes? Boo! You're supposed to have it every day. She knows, but doesn't bring it. Yes, go grab it in your locker. Do you have it? Do you put it in already? These numbers? Eddie? You did it?
Yeah, I went ahead.
Okay, I'm not mad. That's fine. Cool, okay.
Thank you.
So let me put this in here. Okay. believe
Can I just go to the bathroom real quick?
that's fine since you're done with this. Okay, so I put in all my numbers, right, in my first list. You can go ahead, I mean, since we're here, menu, statistics, one variable stat, calculations, blah, blah, right? And we get the 5-number summary. So I'm going to wait till you get to this page. Do we remember how to make a plot, right? A histogram, do we remember how to do it on our calculator? If you're on this page, you always can go, document, insert, and then if you click on data and statistics, it would take you. Otherwise, you can go back to the home page and click on the red button. Okay, sorry, let me go back. Okay, so you're here, you already did the stat calculations? Yeah. Okay, so you're here, cool. So you either can go to the home and click on this red button that says like stat, data and stats, or if you're here, right, if you're on this page, you can go document, insert, and then you can click on data and statistics. There's like 2 ways to get to that page. Okay, so if I click on it, this is what pops up. Because remember, I had to name the list. So if I go back to my list, I had to actually name the top. I had to name what the list would be, otherwise it won't pop up. So I named mine lab. So I go back, oops. And I have to click to add variable before I can do anything on the bottom. You have to add the variable. Cool, I click lab. And remember, we're trying to make a histogram. So to change to a histogram, to go menu, plot type, histogram. And this is, I mean, it's okay, but like, you see how many like bars there are? Not ideal. So if I could, oops, hold on. So if I click menu, plot properties, where is it? Come on, scroll down. What? Okay, that was not what I was supposed to do. Oh my god, why is it clicking crazy? Go back. This is what I get. So I want plot type, histogram, and I want to change the histogram properties bin settings. And then you can change. Right now the width is only 2. If I put something like 5, that would be much better. And then, oh my gosh, I have to scroll over to the left side and drag this down. Why is it doing this? Oh, is it centered around somewhere else? I'm gonna have it be centered around 60, not 61. Come on, go back. There, that's much better. Okay, I'm trying not to go too fast because I entered all these in beforehand. So I made a histogram. Copy this over onto my. Ooh, I have to change this. Onto my notes. Construct a histogram. Wish I could just copy this and go over. What? Oh my god. Oh my god. I don't know. My computer's freaking out right now. Come back. Okay, are you guys all at this step? No? You say you're not? Which part? You entered in all your numbers, and you know how to make the histogram. No. So did you go to the plot page? Okay, yeah, Frankie, show her. So yeah, I'll show you how to do it again. So if you like draw it, it's just easier for me just to copy it over, but if you want to draw it, that would be ideal. I'll show you how to draw it. I can go back and show you how to do it again. Okay. So I'm at this page. You can like click the home and you can go back and this is what will pop up. Now, did you name your list? If you did not name it up here, it's not going to show anything for you when you click on this. Are we all at this? You're at this step? But doing it for her is not going to help. Okay, now you understand it. Okay, so you're here. You clicked add the variable. Here we go. This is not a histogram. So I have to go to menu, plot type, histogram. This is not ideal. I mean, it's okay, but it's not as useful. I want to make the bin size larger. I want to make the class width larger. So you can go to plot properties, histogram properties, bin settings. Oh my god, so much stuff to click. And I can make it maybe a width of 3. Does this look better? Not really. So this is you playing around with it. I also don't want it just to start at 60. It'd be better if it started like, instead of 61, like 60. A nice even number, because this is how we learned about histograms. 3 is still pretty small. If I do something like 5, it makes it much better, but the issue is now it's off my charts. So if you scroll over, you can actually like pull this down so you have a better histogram. Okay. So hopefully by now you've had enough time where you got that on your calculator, and now we're, come on, and now we're drawing it. So, because you will have to draw like on your like partner quiz, you're gonna have to draw these 65 through 70, I do through 69. 70 through 74, 75 through 79, 80 through 84. Oof, did not make this big enough, but you get the idea. Etc., etc. What is the shape of this distribution? It's roughly symmetric. Like it's roughly symmetric. It's not a huge skew. I mean, you could argue with me it's skewed, and I see your point. It's not perfect. It's not perfect, but in terms of like our class, this is about as symmetric as I can give you, and that's one thing we're gonna learn next time. Just a moment. It's one thing we're gonna learn next time is the normal distribution is perfectly symmetric. Like the more data values you have, the more it will fit this bell curve shape. So instead of having, I don't know, 1, 2, 3, 24, what if we had 24,000? Ooh, 24,000 grades, lab grades. It would be a better symmetric, perfectly bell-shaped. Versus here we only have 24. This is about as good as it's going to get. So this is going to be symmetric. Do you have a question?
Yeah, when I did it, I kind of, I like did it separately. I want 60 divided by 8.
You did by tens.
Yeah, so wouldn't it be different depending on how you number it?
So I'm looking at your picture, and it looks roughly symmetric. It's roughly the shape of a. Do you know what a bell curve looks like? It roughly looks like a bell curve. it's not perfect, but for us, something skewed is going to be much, much more like drawn out. Yeah. It's also because you went by tens. So you only had like 4 blocks versus going by fives, you have 8 more blocks. If you go by twos, it's, then you get into the individual data values cause more variance. It's roughly symmetric. So, okay, since it's symmetric, this means we can use the mean. Of course, you finished drawing this out, but I feel like you know how to do the little bar graphs. Like you've drawn bar graphs for years, hopefully. So, since this is symmetric, we can use the mean and standard deviation to talk about the summary of the distribution of the data points. So our mean, remember that's x bar, standard deviation is sx. So the mean is 81.25, the standard deviation is 9.5. So remember how we got those? I just go back to over here where I did the one variable stats. Here's my mean, 81.25. I'll go down to sx, 9.5. That's fine. And see this this sigma x? It's saying, okay, I gave you 24, right? These are the 24 lab grades. What about all the lab grades of all the kids across America doing this one lab, because say this is an AP class, right? Ooh, okay, your calculator is trying to be smart. It's trying to give you the population, the standard deviation for the population, not just our sample of 24. So if you would do it by hand, remember the way we learned about standard deviation, you do all these by hand, this is the number you get is 9.5. Okay. Questions so far? We okay? Okay. Cool. Yeah. So today is a lot of plugging things in on your calculator. Sorry, did you need to see this again? So since it's symmetric, we can use the mean and standard deviation. Clusters. All right, clusters are a subgroup of numbers in a data set. If a distribution of data has 2 modes, therefore 2 peaks, we call it a bimodal. Two modes. There's 2 groups. And I kind of talked about this in the realm of grades. Unfortunately, a lot of times I give a test. There's a bimodal distribution. There's 2 distinct groups of like how people score. It is what it is, So there's 2 clusters. Here's one. Here's the second. You can see it's roughly peaked around these 2 tops. So the number of minutes that 30 members of a high school cross-country team ran during a practice session are shown. Construct a histogram and use it to describe the shape of the distribution. I wonder what it will look like considering what I just taught you. Have any guesses? What will it be? Bimodal. It will be bimodal. Surprise. Okay, so I'll pause the screencast. Okay, so we entered in the numbers. It's very important for you to name this list. So the very top, not where the equal sign is, but the very, very top, I just called it times because these are representing the practice session time in minutes of this cross-country team. So you entered in all the numbers, right? This is what takes the longest, is entering in the numbers. Okay. Then you find, right, all your little stats, menu, menu, statistics, stat calculation, one variable stats, yada yada, right? So I got it all in. And then to make the plot. So you have to name your list, otherwise it's not going to work. There's 2 ways to do it. You either can click on Document, Insert, Data and Statistics, or you can go to the home screen, enter in push on the little like red, purple button that's like the bar graph. Okay, so I have it here, pops up. I have to go down to the bottom, click to add the variable. Well, only one thing pops up, times. So we're trying to make a histogram. So now that I selected the variable, you have to go to your menu and change the plot type. I'm going to change the plot type to a histogram. So right away, this is pretty funky. Your calculator defaults to a bin size of 2, right? A width of 2. I don't know, maybe not as useful because it takes into account I want to see more like clustering. So I need to make a bigger class size, a bigger bin size. So if we click on menu, plot properties, histogram properties, bin settings, equal bin width. Whew, okay. I can go in and I could try a width of 3, 4, or a nice little like 5. 5 would be great. Because then it makes it like, oh, 10 to 14, 15 to 19, right? It makes it nice and easy to see. Okay, it goes off the page, so I have to go to my left side, scroll this down a little bit, and I see very clearly this is a bimodal distribution. There are 2 clusters of data, 2 clusters. Is this what you got? Yeah? Okay, perfect. So I went by 5s. Sometimes, since our data is going from like 20 to 60, I didn't want 40 bins, but I also don't want 2. I want enough bars so it shows me interesting things, but I don't want too many bars so I'm overwhelmed. So what would be better? So we see this is bimodal. What would be the best way to do B? All right, the summarizing the center and spread. Should we use the mean and standard deviation or the 5-number summary? What do you think?
5-number summary.
Probably, because it's not just a nice symmetric. It's got some weird, funky stuff happening. So you can use a 5-number summary. Are there questions how I went through the bars? All right, did you see how I changed the width of the bars? I could have went by 3s or 4s, but like 5 is a nice number because when you draw it on your paper, you're going by 5s. Now, of course, if all of my data was within 5 numbers, okay, I'd go by 1s or something. You have to look at your data. So I'll go back to the 5-number summary, and we will write it down. Okay, so min was 22, Q1 was 32, Q1. Median was 45.5, Q3 was 54, and our max was 64. So it's pretty spread out, All right. Ready for our next one? Do we need more time? We're okay. Feedback is great. Okay. So far we've been looking at histograms, bar graphs, skews. Okay, symmetric versus positively or negatively skewed. What if I want to look at a box and whisker plot? What will those look like? Sorry, did you need more time? Do you need more time to draw it? Yeah, I should give you a little more time. Okay. I don't want to rush you guys because it's literally like we're just doing 5 of these examples. Yeah. It's like four of these types of examples and then one where it's like, I don't know, a little differently. So you will have to draw this bar by hand, but you have your calculator. Like literally at that point, the hard part is you messing around and making sure the width of your histograms are solid width, and then you can literally just copy it over from your calculator. I believe on the quiz I put a graph on there, so that way you just have to draw the bars and label your axes. You don't actually have to draw this type of thing yourself. I actually put the grid of the graph on there. Okay. So there's not tons of homework associated with this assignment. Notice a lot of this is just repeating. Enter it in your calculator, do the stat calculations, what are the 5-number summary, what's it mean for standard deviation. This should be a solid quiz. That's the goal. Cool. Okay. Do you need a little more time? Yeah, I just don't want to rush you guys drawing this stuff. All right, box and whisker plots. So, symmetrical, very, very evenly. Literally all the widths are even. Versus negatively skewed, you have a whisker going out to the left. Versus positively skewed, your larger side is on the right. So you're just looking, where's your larger whisker? Where's your larger part of your box? versus these two whiskers are going to be equal size. So more or less, look where your whiskers longer. Look for your box, which part of the box is larger. So the costs on a used car website for 12 trucks that are the same make, model, and year are shown. Construct a box plot and use it to describe the shape and size, the shape of the distribution. So once again, I am asking you to enter these into your calculator. Aha, you got it? Yes. So I already inserted all these numbers in my calculator. I did the stat calculation, right? So I'm just finding my 5 points. I'm going to draw my bar graph, and then I'll like go through my box and whisker, and then I'll show you how your calculator can do it for you. Cool. Hopefully today is not too bad. It's not like tons of new stuff. It's a nice semi-review. It's just saying like, oh, how not only do we have variance in our data spread out, but how is it spread out? It's just taking it one step further. That's all we're doing. Right here. Okay. My middle three. So just based on this rudimentary box and whisker, I see my whisker on the left side is larger, so this is going to be negatively skewed. I'll show you how to do the box and whisker plot on here, and then I'll give you like a minute to like make sure you're caught up with writing and stuff. Cool. So you can go to the home screen, click on this little red, purple, add data statistics. Remember, you have to name your list in order to actually click to add variable. All right, so I click on it. I have to click menu, plot type, box plot. Check it. This looks perfect, exactly like what I drew. If only what I drew was a little nicer than that. Okay, so roughly, this looks roughly the same. You know, you can see how this whisker on the left side is larger. Cool. Whisker on the left side a little larger. Same thing. So since this is a skewed, do we want to use the standard deviation and mean, or is it better to use a 5-number summary? When you have something skewed, 5-number summary. So that's what we shall put.
Isn't it easier to only do 5-number summaries?
Well, I mean the mean and the standard deviations on your calculator as well. So if you have something that's symmetric, you might as well just use the mean and standard deviation. Yeah, I'm distinguishing when you use them. Symmetric, use standard deviation and mean because those are non-resistant. Versus when something's like skewed, it's better just do the 5-number summary. Okay, so I would like to keep going. But a moment. Yeah, so it's just like 6 problems, not too bad. Yeah, because the next, like the second day I planned, it's honestly like 10, 15 more minutes. That's all it is. So we're just going to do it, and then tomorrow we'll do 11-3. And then we'll have a day of review, and then we'll have a day of the quiz. Perfect. Yeah. Cool. Do we need a little more time to write this down? Are we okay? Oh, you guys are done? Sweet. Let's keep going. I see everyone on the next page already. So, measures of position. So the quartiles given by the 5-number summary specify the positions of data values within the distribution. For this reason, box plots are the most useful for side-by-side comparisons with more than 2 or more distributions. Hello. So when we can like compare 2 different box and plot diagrams. So this is what I do on the regular. I have 2 sections of precalculus. I look at how is the spread for this section versus the spread of the other one. Right? I have 2 sections of intermediate algebra. How are my test scores with one of them versus my test scores of another? So I'm comparing the 2, and I'm saying, okay, why is this section higher average than the other? Like, what's going on here? And so it helps me try to help you better, right? So I can compare 2 different things. Here,
does one section tend to be higher than the other?
100%. Yep.
Why?
And the thing is, so with precalculus on the regular, it's this section scores higher because you guys are smaller. You're literally half the size of the other class. So if you think about, I can answer all of your questions, right? And we just get through things faster. We're a smaller group. So I that's 100% why that happens. With my intermediate, it switches back and forth. Yeah. Sometimes it depends on like with precalculus, like if I had 5 people drop down from honors precal to my regular precal, like they're scoring really high, and so it skews one section higher than the other. Okay, cool. You also can compare like the batting averages, or maybe like Jolie, your kill ratio one year versus another year. You can like see how you're improving as well. So it doesn't just have to be test scores. But for me, this is like that's what I use it for all the time. So here we can compare the number of home runs in MLB in 1927 and 2007 with the top 20 home run hitters shown. All right, so we're going to construct side-by-side box plots of the data sets and then use this to display to compare the distributions. Okay. It's a lot of numbers. Whew, it's like 20 for each. Okay, so let me come back up here. Do not save. Okay. So this is the 4th one. So I want to tell you how to set it up because you have 2 different data. So I put all the 1927 in row 1, column 1, all 2000 in column 2, and then we kind of did this before. Your stats, if you do the stat calculations for the first column, it's going to try to put it in the second column. Warning you, don't let it do that, right? So you do C and D for the first column, and if I scroll over, E and F are the stats for the second column. Just want to like prepare you. Okay, so go ahead and enter all these in. Enter all these into your, one more page, into your calculator. This will take a couple minutes. Enter it into your calculator. We are all here at this step. The next thing to do, you can click Document, Insert, Data and Statistics, or you can go to the home page where that little button is, right, that I've said about 50 times. Cool. Okay, I have to add a variable. I'm going to add my 1927 first, right? I said HR 1927 home runs. Cool. Okay, and remember what we're trying to do? Box and whisker plot. So click Menu, Plot Type, Box Plot. Okay, we're here, and then we're almost done.
Wait, yes, there's one.
Yeah, they're there. It just took a sec. Ooh, yeah. What the heck? This is supposed to be box and whiskers. So I'm going to say Menu, Plot Properties, extend these whiskers out. Whiskers. Extend my whiskers. There we go. Fixed.
Wait, what?
Extend whiskers. Menu, Plot Properties, extend whiskers. Okay. That is 1. Right? The 1927 one. Okay. Now if you go Menu, Plot Properties, add X variable 2007. Check it. Hey. Wow. Okay. Wonderful. Wonderful. Let's do some analysis on this first, right? Are these box plots symmetric or are they skewed? Are these box plots symmetric or are they skewed? They're skewed. Which way are they skewed? Positive, right? They have a positive skew. On the right side, our whiskers are longer. So there's more people hitting higher than our median, right? Our mean is going to be higher than our median. One thing I want you to notice, right? The players in 2007, that's the orange, that's the bottom one, they hit more home runs on average than the people in 1927, right? You see the mean, the most, right? Most people are above the majority of people from 1927. But notice, there's someone who beat everybody from 2007, right? The max home runs, the biggest number, happened in 1927. Okay, so things I want you to notice. You can draw like two box plots on the same graph. The thing when you draw it on your paper, you need to have equal space here. And you know from these stats the 5-number summary. Literally, this shows you what it should look like. You go back to the 5-number summary and you should be able to like draw these relatively easy on your own. Right? So I scroll over and I have all of my data. Scroll down, I see here's my 5-number summary I can use to draw my box plot. So let's do it. Did you guys draw this already? Okay. So just because this is the notes I'm going to upload, I want to show exactly what will show on your calculator, and then I will draw it on the notes. Okay. Cool. You just have to make sure you have equal tick marks on your axes. And the reason I say that is because when I taught science, this was a big thing people did not do. Make sure we're good. Okay. I'm going to use my 5-number summary. Okay. Okay, then my other one, let's see. Just looking over the 5-number summary right here. I don't think these are too hard to draw. How are you finding them? Is it okay? Struggling? Let me know. Spend more time on it, but I believe in your guys' abilities. Alright, because we spent a whole day on these puppies. Okay, it's roughly, right, I just used my 5-number summaries, drew my dots. It's not as precise as the calculator, whatever. It's the same thing. The nice thing is, like, I showed you the 5-number summary on your calculator so you can get those numbers, but I also showed you how it will graph it for you. That way you can make sure what you're drawing is the correct solution.
It's good enough.
Right, this is close enough, right? I see what I'm supposed to. All right, this quiz is not supposed to be like a tricky. This is supposed to be like a, did we get it? Did you get some stats? We're solid. Awesome. Let's do this. All right. Not supposed to be tricky. So what are we supposed to do? Use it to display comparisons. Okay, so now we're supposed to compare. It's kind of what we talked about. All right, so we drew the box and whisker plots for both of our data sets. Let's compare them. Players in 2007 hit more home runs. Hit more home runs on average than players in 1927. I wish I could. Nope. Oh, that's better. Okay. But however, notice the max was 60, and that was in 1927. Yeah, okay. Not too bad. So I'll try to make a review for you guys for Wednesday for us to go over, and then, I mean, you'll have time to like work on homework that day as well. So hopefully solid. Robert, you were here at first. If you didn't turn in all of the like the 2 things from last week, you can give it to me like tomorrow and the end of the day, like, because technically I wrote on the lesson plan it was due today, but I mean, I also know it's a lot of work, so I'll give you an extra day. All right, and last page, percentiles. So we started going over this. All right, you take the SAT, you were in the 68th percentile for English. Okay, what this means is you scored the same or above 68% of the people. But this also means 32% of people scored higher than you, right? So the percentile, it tells you the position of your individual data set, value within the whole data set, right? You divide the distribution into 100 equal groups. The nth percentile means that much percent are below you. And then if you do 100 minus that percent, it tells you how many people are above you. So imagine you're the 99th percentile. You score better than 99% of people, right? That means you are the top 1% of the test. Another thing you hear in the news is like the 1%. That means, oh, they are the 1% people who are the richest, right? They're literally the top 1%, means they're richer than 99% of people. And if you go into the 1% of wealth, right, you'll see, oh, there's even large disparities inside the 1%, right? The 1% of the 1%, ooh, crazy. So all these percentiles, like this is when it comes up in the news. What else do I want to say about this? Percentile graphs, 100%. There will be a percentile graph on the quiz. So we're going to go through this. This table gives the frequency distribution of the heights of girls in Mr. Lee's pre-calculus class. Fun fact, Mr. Lee was my calc teacher in high school. So yeah, he still asks about me. He's so cute. No, this is from the book. But he's so cute. He still asks like how I'm doing. He like calls my mom. Yeah. What else do I want to say about this? Is there anything else I described? I like to write notes for myself to make sure to tell you things. No, we're good. Okay. So here are the class boundaries, right? We split it up. If I would draw a histogram, it would tell you how high the histogram is, right? So this is 11 high versus 15 high. What I would like to know is like, okay, what percent is this, right? What percent of the distribution is within these bounds? What percent of the distribution? So to find the percent, you take how many out of the whole. So what's the total number of girls we're looking at? You got to add up all the frequency. All right, 11 plus 15, 26, 41, 53, 60. So the total is 60 girls. So to find the percent, right, we're going to do 11 over 60. So that's 18%. Then, right, 15 over 60. Okay, well, that's 25%. 15 over 60, 25%. 12 over 60, that's 1/5, so that's 20%. Ooh, 7 over 60, 12%. Because it has to add up to 100%, right? If we only have 60 girls, at the end, all of these are supposed to add up to 100%. It has to represent all of the girls here. Give you a sec to write that down. Because the next thing we're looking at Star star is the percentile. So starting at 0, right? So the people who are, if you would score exactly, or I guess if you were exactly 61.5, was it inches tall? I think so. If you were 61.5 inches tall, you are the 18th percentile because you are taller than 18% of people. So the percentile, you add up all the previous ones. Well, guess what? The first one, there was no one smaller, right? It's literally the first class boundary. But imagine you are 64.5 inches tall. You are the 18 plus 25. You are the 43rd percentile, because that means you are taller than 43% of the girls in that class. And then you just like keep adding. Okay, now if I add 25 to 43, we get 68. So if you were, let me make this a little more clear. Okay. So if you were at this boundary, right, 67.5 inches tall, if you were 67.5 inches tall, you are taller than 68% of people in your class because you were taller than all the people above you. Okay, so gotta add the next one. If I add 20 to this, you get 88. All right, because we're adding all the previous ones to get 88. And then lastly, if I add the 12, what do I get at the end? 100, and it should add to 100, right? We had to have everyone represented. If you are 73.5 inches tall, you are taller than 100% of these girls in this class. And then constructing a percentile graph of the data. Okay. Let's see. 10, 20.
Isn't it impossible to be in the 100%?
Technically, yeah, you'd be like the you would be the 99th percentile. That's as high as the things will go. Yep. 50, 60. Did I not make this large enough? 90, up here. Okay, these are percentiles. Try to make them as equally spaced as possible. It's the goal, percentiles, and then we're having height in inches on the x-axis. Oof, because I need to make sure this is I'm only focusing, see, 58, 60, 62, 64, 66. Okay, cool. So our graph, our lowest number is 58.5. That's about right here. And then let's see, at 61.5, we're at 18. So at 61.5, we're about 18, which is about here. And then so I'm just doing the boundary. 64.5, we're at 43%. 64.5, we're at 43%. That's about right there. Let's see what's the next one. 67.5, we're at the 68th percentile. 67.5, we're at the 68th percentile. So right here. And then at 70.5, we're at the 88. 70.5, we're at the 88, which is about right here. And then our tallest is 73.5, so it's right here. This is just a percentile graph, because then if I say, okay, if you are 64 inches tall, what percentile are you? Or, example, the next one, if you are 68 inches tall, let's see what percent it would be. 68's right here. Seems like it would be about the, let's see. Didn't really draw this nicely. 60, 68. Oh my god, this is so hard to do. 68 is about right here. I don't know, about the 72nd or so percentile. 70th percentile. It looks like it's about 70. About 70 percentile. That's it. That's how you do it, and that's the whole lesson. So that is like 7 through 15. So it's just like 15 problems for today's lesson. Hopefully not too bad. Were there any questions? Okay. So we will do the last lesson tomorrow. We'll review, have time for homework Wednesday, and then Thursday is your partner quiz. Cool.